Section 3.4 is continuing on with some of the theorems that we've been learning, but now we're going to be looking at some triangles. The first theorem in this section is the triangle angle sum theorem. This just tells us that the sum of the measures of the angles of a triangle has to be 180 degrees. And so with the triangle that's pictured, using A, B, and C, the measure of angle A plus the measure of angle B plus the measure of angle C has to equal 180 in any triangle. So, for example 1, we're going to find the values of x, y, and z. We're given, this really could be three triangles. We have FGJ, we have GJH, and we have FGH, the larger triangle. So I need to look at each one separately as I need to be able to figure out what x, y, and z are. The first one that's easiest to find is x. If I'm looking at the triangle FGJ, I have two of the angles given, angle 65 and angle 39. So according to the triangle angle sum theorem, I should be able to add 39 plus 65 plus whatever x is, and that should give me 180. So I just simply add these two up and I get 104 plus x equals 180. And then I subtract 104 from 180 and I get x equals 76. Alright, that's the first part. Now I also need to find y and z. So for the triangle GJH, there are two angles that I don't know. So instead I'm going to look at the larger triangle FGH. There I have angle F has a measure of 65 degrees, and then angle G is made up of the two angles 39 and 21. So together those would be 60 degrees. So I'll be adding 65 degrees plus 60 degrees, and then also Z, whereas that's angle H. That should add up to 180. Okay, that would give me 125 plus Z equals 180. And so I would subtract 180 minus 25. That will give me 55. So Z is 55. Once I know Z, I'm able to use the small triangle GJH, to find angle Y. So I'm going to add 21 plus Z plus Y equals 180. But I know that Z is 55, so 21 plus 55 plus Y equals 180. So that's going to end up being 76 plus Y equals 180, and then I'll subtract 180 minus 76, which would give me 104. Okay, there was another way that you could work this problem out. Once you find x, you could have chosen to look at the fact that x and y are a linear pair, so they have to add up to 180. And so you could have found y by subtracting x from 180, or 76 from 180. And then you could have used, again, triangle GJH, and to find z in that case instead of y. So there's not always only one way to find it, but sometimes there might be one way that's easier than another. In this case, they were about the same. Okay, another thing we're going to do in this section is to classify triangles by angles and sides. And you've probably seen this before, but maybe you just haven't done it in a while and you don't remember the names. So we're going to go over what these are. The first one is an equiangular triangle. In this case, all the angles of the triangle are congruent. And if you'll notice, the angles are all marked with one arc to show that they're all congruent to each other. Now, one thing that we do know from the triangle angle sum theorem is that those all have to add up to 180. And if they're all the same, then each of those really has to be 60 degrees. So any equal angular triangle is going to have 60-degree angles. All right, the next kind that we're looking at that has to do with angles is acute. So an acute triangle just means that all the angles are acute, and which means that they're less than 90 degrees. All right, then there's a right triangle, which means it has one right angle. The other two will have to be acute, otherwise they would add up to more than 180. And finally, of the triangles that are classified by angles is the obtuse triangle, and in that case there's one obtuse angle in it. The other two have to be acute, otherwise they would add up to more than 180. Now, the three of the ways that we can classify triangles by their sides, the first one is an equilateral triangle. Notice that here we've marked all the sides with one line, which means they're all equal to each other. So here all the sides are congruent. It turns out, we'll find out later, that equiangular triangles are always equilaterals, and equilateral triangles are always equiangular triangles. The second kind is an isosceles triangle. Here we have at least two sides that are congruent. Technically, an equilateral could also be called an isosceles, but it's a special case of an isosceles. So you're always looking for where they have two sides that are the same. Often those are called the legs. The last one here is the scalene. That means that there are no sides that are congruent. So everything is a different length. So here in example 2, they're asking us to classify a triangle both by sides and angles. So if I'm looking at classifying it by sides first, I'll notice that the two sides are both marked with one hash, so that's telling me that these two sides are congruent. So I know it's an isosceles. Now about the angles, I'm looking at it to try to figure out how could I classify it as either equiangular, acute, right, or obtuse. I don't have a right angle marked, so it can't be that. I don't have all three angles marked the same, so it can't be equiangular. So that means it would either be acute or obtuse. Remember, obtuse is greater than 90, but less than 180. So just by looking at it, this one has to be an acute triangle. So it's an acute isosceles triangle. I spelled that wrong. So you'll be asked in some of your homework just to look at and classify some triangles. Sometimes they want you to draw out triangles that match their description if you can. So on the first one, part A, see if you can draw an acute scalene triangle. So think about what that means as Vic is sneaking in the room. It's a little entertainment for these guys listening to geometry video that might be boring them right now. All right, acute is relating to the angles, so we know that all the angles have to be acute, and scalene is telling me that none of the sides can be the same length. So your triangle might look different than my triangle, but we just need to try to make it look like maybe it has different side lengths, and the angles must all be less than 90 degrees. The second one is an isosceles right triangle. So see if you can draw a triangle with a right angle that has two sides that are the same. Okay, so again, your triangle might not look exactly like mine, but it might just be turned a different way. It's going to look pretty much the same because we really have to have the same side lengths on two sides. So the two sides that are the same are always going to end up being the ones that have the right angle between them. And we'll learn more about that as we study right triangles. Finally, they want me to draw an obtuse equiangular triangle. Now think about what we said a few minutes ago about what equiangular means. And ask yourself, can I do this? Can I draw this triangle? So we said equiangular means all their angles are the same, and if they all have to add up to 180, that they end up being 60 degrees. Well, obtuse has to be greater than 90 degrees, which 60 degrees is not. So there's no way that I can draw an obtuse triangle that's also equiangular. That would mean all of the angles were greater than 90, and there's no way to make a triangle because the legs wouldn't connect. So this one would just be not possible. We can't do this one. Okay, here we're going to look at another an angle that's defined about, well, outside of a triangle. So if I extend one side of a triangle and make it look like it's going past the rest of the sides, it's just an extension there. If the angle that's formed between that extension and the side of the triangle is called an exterior angle because it's on the outside of the triangle. So exterior means outside. And then the two angles that are opposite that angle, not adjacent to it, so I'm not talking about this one here, but angles 2 and angles 3 are called remote interior angles. Remote means, think about remote on your TV, you would be using it from far away. So the exterior angle is far away from the remote interior angles, not next to it. Okay. So for each exterior angle, there are going to be two remote interior angles. It's depending on where you extended a line. I could extend lines in different places around this triangle if I wanted to, and have some other exterior angles here. But in that case, the remote interior angles are never the one that are right next to it, or the adjacent ones. So I'm going to mark that out. So I can just undo it. Okay, now, so look at Theorem 313, called the triangle exterior angle theorem. This says the measure of each exterior angle of a triangle equals the sum of the measures of its two remote interior angles. So remember, each exterior angle has its own remote interior angles. It can't be one of the ones that's adjacent to it, but it always has to be the other two in the triangle. So writing this out using my picture here, measure of angle 1, which is the exterior angle, has to equal the measure of angle 2 plus the measure of angle 3, which are the remote interior angles. So this is my exterior, and these are my remote interior angles. So when I add up 2 and 3, it has to equal the measure of angle 1. Now let's see how we can use that. All right, so for example 3, part A, they're asking me, well, A and B, they're asking me to find each missing angle measure. So the missing angle measure is the one that has the number that doesn't have a degree next to it. So in the first one, measure of angle 1 is my exterior angle. It has to equal the sum of the remote interior angles, which are the ones that are given, 40 and 30. So measure of angle 1 must be 70 degrees. In the part B, they gave me one where the exterior angle is 113, so I know it, unlike the part A. And I know one of the remote interior angles, but I don't know the other remote interior angle. So I'm going to write down, using the exterior angles theorem, 113 has to equal 70 degrees plus the measure of angle 2. So if I subtract 70 from 113, I will get 43 degrees. Should be equal to the measure of angle 2. All right, quick check 3. I want y'all to try that one. All right, hopefully you recognize that angle 3 was my exterior angle. So the sum of the two remote interior angles, 45 plus 45, has to equal the measure of angle 3. So measure of angle 3 will be 90 degrees. Okay, that was the last slide for this section. So try these problems out. If you need to go back and listen to the video again and watch the examples, then do that. And Send me any questions you might have.